Hi, everyone. Welcome to the first biweekly event hosted by the DevOps Learning Space, DLS. So this is our first biweekly event, and we're basically just discussing the topics that we covered in the DLS curriculum. That's the learning curriculum that's available to all the community members that have joined DLS community so far. So for today, would basically be talking about some concepts in DevOps. I'll be starting with as a keynote speaker. I'll be starting and I'll be discussing briefly about what is DevOps, definition, principles, and practices, what DevOps consists of, understanding the software DevOps learning space. The sorry about that, the software development life cycle, limitations of the traditional software development life cycle. I will talk about the benefits that DevOps offer over the traditional system of software development life cycle process. I will discuss this set of practices and terms used in DevOps. I will discuss case studies and examples of companies that are actually using DevOps today, like real life examples. That's basically what I'm going to cover in my own, my own session. So we're going to have a couple of other sessions with amazing speakers. We have Victor in the house. Victor, if you're here, please can you say hi?
Hi guys, it's really nice to
Uh,
be part of the biweekly meeting.
Yeah, so thank you, Victor. Victor is one of the DLS coordinators within the community, and he's a software developer, a very proficient software developer, and he's also a technical writer as well. And we also have Elvis Anselm in the house. Elvis, if you're here, say hi.
Hey guys, happy to be here.
Thank you, Elvis. Elvis is also a technical writer and is one of the DLS coordinators. We also have Treasure in the house and myself. So, without further ado, let's get right into it. So first, I'm going to start with discussing what DevOps consists of. So DevOps is like it's I think recently where we're hearing the word DevOps in the tech community. Everybody wants to learn DevOps. So most people don't really know what DevOps is. So I'm going to like use this session to describe and explain to you what DevOps is in a very simple terms. In like I'm not going to give I'm going to make it as simple as possible and make you become very conversant with DevOps. So, first of all, DevOps is a set of practices that fuels the collaboration between IT teams, software developers to automate the operations involved in both development and IT to achieve faster software deployment and code quality. So basically, that's what DevOps is, right? It's like that's like a lot of buzzwords put together. But don't worry, I'm going to like give you more explanation as we go on. So first of all, I think I'm going to discuss the software development life cycle. So before understanding what DevOps consists of, you need to understand the software development life cycle process. So before you become very proficient with DevOps, and before you even start your learning journey in the DevOps field, it's very important that you understand the software development lifecycle process. So this software development lifecycle process is actually made up of or consists of a hierarchical structure, like stages basically. So basically stages in a hierarchy format. So we have the planning stage, as you can see on my screen. You have the planning stage, analysis stage, the design stage, the implementation stage, the testing stage, the deployment stage, and the maintenance stage. So these are those stages that occur in a hierarchy format. So it starts from this planning stage to the analysis stage, and then so on and so forth. So the planning stage is basically the scope that consists of by scope I mean features and functions of a project. So in the planning stage, that's where the features and functions of a project, that is the scope of the project, is defined, and all that is required, to develop the project is also identified, right? Then we also have the analysis stage. So this analysis stage is where I have like an illustration on my screen. So I felt it would be better to explain the analysis stage if you have like a pictorial understanding. So I designed an e-learning platform. Like I did designed a simple system architecture for an e-learning platform. So the analysis stage, which is the next stage that follows the planning stage, which is where you define the scope of the project, right? So this stage basically analyzes the requirements that you gather. So in the planning stage, that's where you gather all the requirements for a project. So let's say you want to build an e-learning platform, and that is the name of the project you want to build. So the first thing you do is what you go through the planning stage, where you would um, discover the requirements, find out the requirements that is needed and is required to build this e-learning platform. Then when you get those requirements, the next stage is the analysis stage, where you analyze the requirements that have been gathered. And those requirements could be, components that make up the project. And by components, I mean the building blocks that would make up the system. For example, you have the hardware, software, data exchange mechanisms, the data itself, interfaces that promote interaction between the components and the subsystems, and also the network infrastructure for running and deploying the application, right? So those are the components that make up the system. Those are the components that make up the project. So what you do in this analysis stage is basically gather those requirements. And when you analyze those requirements basically that are gathered, then you define their use cases. Like, okay, what are the use cases of these components? What is this component used for in this project, right? And then use those findings to conceptualize a system architecture. So what I have displayed on my screen is basically a system architecture of the project, right? I remember I said that the project I'm using in this scenario is an e-learning platform, right? So this is the e-learning platform. So, and this is the system architecture. And what this system architecture is showing is basically just defining how the system components will work together to achieve the project end goal. So the e-learning platform, as the name implies, is just a platform where students can sign up on the platform and learn courses. Let's say take courses and learn those courses, and also teachers can sign up as well. We call them lecturers. So lecturers can sign up and log in on the platform and then be able to teach students, right? So the system architecture, as you can see in the illustration I have displayed on my screen, we have the e-learning platform user. And now the e-learning platform is comprises of several components. We have the component that has to do with user authentication. So user authentication, if you're a developer, you would be conversant with the term authentication. So authentication basically is when the user signs up on the platform and then logs into the platform and is authenticated and then verified. Okay, so the first thing that happens obviously is the user registration. So the user would first register, and then when the user registers, the app authenticates the users, and then there's the admin login part on the platform, there's the lecturer login part on the platform, there's the student login part on the platform, and then under the admin login we have basically the components. Under the admin login we have the view user profile, where the user profile is being viewed, where the admin can perform functions like adding a new user, managing users, managing resources, managing courses, right? Then the lecturer login component, basically the functions like updating profile, answering queries, uploading or downloading, providing questions, and kind of functions that take place in this for this lecturer login component. And then under the student login component, you have functions like updating profile, posting questions, submitting answers, viewing question, and downloading files. So this is like the basic summary of what happens in the analysis stage. Then we have the next stage, which is the design stage. So remember, I'm talking about the software development learning. Sorry, I keep saying learning because I keep going back to DevOps Learning Space, right? Sorry about that. So I'm talking about the software development life cycle. So this is the third stage in the software development life cycle, the design stage. So what happens here is basically, where you create a detailed design from the software architecture, including the user interface and the database schema. So basically, you use the software architecture that you have, conceptualized in the analysis stage to design a software, a system design, to design a system that basically shows the details basically shows like things like the database. I have another illustration on my screen that's showing it that's showing a simple design, a system design, right? So what goes in components like database, the web app servers, caching service, job servers, full text search service, services, data, data warehouse, data firehouse, cloud storage, copy of data, the CDN, user browser, basically the details basically of that software architecture. So like I showed you earlier in the analysis stage, like software architecture for the e-learning platform, you see that it's like an overall component structure for the platform. Like there are no details. I just said user authentication, but there are a lot of technicalities that basically go into the user authentication component of the app. So what you now design what will now happen, sorry, in the design stage is the details that have to, that go in the tools that are basically used, like the tools that are basically used to achieve that user authentication, right? Stuff like that. Basically, that's what I'm talking about. So um back to the software development lifecycle, the next stage after the design stage is the implementation stage. And basically, what happens there is the integration of the components that have been designed. So, like for instance, writing the code, right? Writing unit tests. So now you have the components, right? You have a system design of the project you want to build, right? Let's say the e-learning platform. So what you now do next is developers will now like integrate those components, like build out those components. Sorry for the typographical error. That's actually not for the development. Actually, development lifecycle. Okay, so moving forward, the next stage is the testing stage. So in the testing stage, the software is being tested to find errors or bugs before production. So before an application is put out there, by production, you know what I mean. If you're a developer, by production, when the software is made available to users, right? So before the software is being made available to users, the software has to undergo some certain level of test, right, to find if there are any errors or bugs in the application before it becomes live, right? Because when it becomes live, users, would have issues using the application, right? Because of the bugs and errors and all of that, and it will not function based on the requirements of the project. So that's very important. That's a very important stage. Then we also have the deployment stage that follows the testing stage. And what happens here is the application is made available to users to basically install. That's basically. Then we have the maintenance stage where the software monitoring happens to discover any issues, fixes that need to be made, and make necessary updates basically. So these stages basically can be carried out using different kinds of methods. These the stages involved in the software development life cycle can be carried out with different methodologies, and a couple of them exist. You can check them out on Google. Just Google different types of methodologies used in the software development life cycle, and you see a couple. But for this tutorial, I'll just mention two of them, which is the waterfall model and the agile model. So the waterfall model is basically uses a sequential approach. Basically, what that means is, okay, it starts from the planning stage, right? Starts by executing the planning stage and then moves to the analysis stage, right? So it's basically step by step. So it completes each stage before it moves to the next stage. Basically, that's what it means. So the major let me move to the next one. So the major, yeah, I think that's it. The major methodology I would actually want to emphasize on is the agile methodology, and that's because DevOps is based on this methodology. DevOps is basically built on this methodology of the software development lifecycle, right? So the agile methodology is basically uses an iterative approach, not a sequential approach like the waterfall model. It uses an iterative approach based on continuous feedback and communication between a team of developers and the customers to ensure that the software being developed meets the customer's needs and requirements. So that's the agile methodology, and a couple of set of practices happen within this agile methodology. And to list a few, we have continuous planning and prioritization of work, continuous integration and testing of code, continuous delivery of working software, regular retrospectives to evaluate and improve the process. That's basically just an iterative approach. So it's continuous. That's what I mean by iterative. I mean continuous. So there's when a change is made in a code, for instance. Let's say the code had the project has undergone the several stages within the software development lifecycle, from the planning to the other stages, right? And then the project or the application has been made live in production, and users are interfacing with this application. They're using this application, and then they discover a bug in the application, right? And what happens when the user discovers a bug? The developers will have to make some updates to the code, right, in the code which the application which the application was built on, right? So basically, what happens then is when the developer makes an update now in the code, using the agile methodology, it's easy to just easily integrate that update immediately, and the application will continue performing like nothing happened. It will not affect the application's performance, basically. So that's the agile methodology. There's continuous integration, there's continuous testing of code. The testing is continuous. The delivery of the software is continuous. That's the agile methodology, and that is what DevOps is based on. So I don't know if you have like some idea of what DevOps is now. So I think with that, I'll move on to discussing the limitations of the traditional software development lifecycle. So if you remember correctly, I mentioned just now the waterfall model, right? I briefly talked about the waterfall model, which uses a sequential approach, and I said it basically completes each stage before moving to the next, right? And this waterfall model basically has this waterfall model that uses this sequential approach definitely has limitations, because like the analogy I used earlier just now, when a user interfaces with an application that's already live, and then they discover a bug in the application, and then the developers have to make updates to the application using the waterfall model, there's no how it will mean literally rebuilding the whole application and starting all over. Means the application will just pause. It will work for like a couple of hours, or let's say a couple of weeks, or a couple of months, yeah, because it's a sequential approach. Once the application has crossed the testing stage, you can't go back. That's how it is. But with agile, like, it's different. But so let me just point out some of these limitations that this traditional software development lifecycle, like the waterfall model, has, or let's say, what's the word now, includes. So first of all, lack of flexibility. So there's this lack of flexibility when using a traditional software development lifecycle. And it's also, I think I need to point out that DevOps does not use a tradition. Is not based on the traditional software development lifecycle. It doesn't. Sorry, I think the better way of saying that is DevOps is not based on the traditional software development lifecycle methodology. So DevOps does not use the traditional software development lifecycle methodology like waterfall model. So I'm basically just explaining some limitations that the traditional software development lifecycle brought about, that led to the development of DevOps, that led to the whole concept of DevOps. Like, why DevOps? How did DevOps come about? Basically, that's what I'm explaining right now. And I'm listing out some of these limitations, right? I'm explaining some of the limitations that that the traditional software development lifecycle brought about. And one of it is lack of flexibility. So since the waterfall model uses a linear approach, when changes are made later on, like I said earlier, to the software, there's no going back to make any updates. So it results in restarting the entire software development lifecycle all over, which has a lot of adverse effects, right? From lack of customer satisfaction, basically the project will just lose users, it will lose customers. No one wants to use an application that's where, okay, today it's working, then in the next 2 months it doesn't work, that kind of thing. It doesn't make sense, right? So the next limitation is lack of customer involvement. So in building a product that will be consumed by people, it's very important to involve customers in the software development learning process to ensure that the product meets the customer's needs, right? So I mean, what's the aim of a product that customers don't find useful, right? So that's very important. The traditional software development lifecycle lacks that. It lacks the customer involvement. Like, customers are not involved in the software development lifecycle process, which is a red flag, basically. Then we have slow development as another limitation. So the architecture of the waterfall model makes it take a much longer time to develop and make software available to users. Then we also have the high cost involved. So using the traditional software development lifecycle, it means there's going to be an extensive testing going on. So a great deal of testing, which will cost a lot, and also a wastage, because basically when I build an application and I make the application go live, and then a bug is encountered, it means I have to start all over again. That's like a waste of resources, right? And I mean, I'm paying my developers too. I'm paying developers. I'm paying the guys handling the networking infrastructure. So it means I'll keep paying guys all over and over again. I'll keep paying for resources all over and over again, and it will lead to wastage, right? So this high cost is very high. In fact, it's very one of the indications that actually stand out in using the traditional software development life cycle. Let me move forward to discuss how DevOps solves this issue, like the role DevOps now plays, in this to resolve the limitations that the traditional software development life cycle brought about in the world and in the use of projects basically. So one of it is flexibility. So flexibility, what I mean by flexibility is that DevOps itself is designed to be flexible, thereby making up for the lack of flexibility caused by using a traditional software development lifecycle methodology. So the flexibility can be seen in the speed in which DevOps uses to respond to and also make updates to a software. So using DevOps now and not the traditional software development lifecycle methodology, it would mean that since DevOps is based on the agile methodology, which uses an iterative approach, like I said earlier, it's based on continuous delivery, continuous integration of updates and all of that, right? So DevOps would respond and make updates faster to a software. So there's this flexibility, right? It's not like you can always go back to the testing stage. So once you've deployed the application using DevOps, you can always go back to test the application, right? But with the traditional software development lifecycle, you can't do that. There's also collaboration. So DevOps also fosters teamwork for a reliable collaboration and communication between development and operations team. So between the development and operations team, there has to be communication, right? There has to be communication. There has to be a form of collaboration. So DevOps allows this teamwork to exist between developers and the IT and the IT and operations teams, basically. Then there's also quality. So DevOps improves the quality of code with a set of practices like automated testing and infrastructure as code. So there are sets of practices. As you learn DevOps, you would discover that there are sets of practices that are involved in DevOps that actually improve the quality of the code used in a software. There's also customer satisfaction. Like I said, using the traditional software development lifecycle would mean there's no customer satisfaction. But with DevOps, the customers are highly involved in the software development lifecycle process. So I know, like based on the explanation I gave earlier, you would know that okay, wait this far that this would obviously mean that there will be higher customer satisfaction, right? Because the software delivered will basically meet the customer's needs. And also the cost factor as well, the cost benefits, right? So also DevOps largely reduces the cost as it uses an iterative approach, like I said earlier, in place of a sequential approach, which usually requires a rework, right? So there's also faster release cycle, lastly. So the faster release cycle basically has to do with, making sure that the software that is being released or the software release, even after several updates are being made to the software is released very fast. Like there's no delay in the software release and all of that. So those are kind of like, there are a lot more benefits that DevOps offer, right? But these are some of the key benefits that I know that DevOps offer. So I think we'll move forward to see some sets of practices that are involved in DevOps. So when you start learning DevOps, you will hear these terms used a lot. You hear the continuous integration term, the continuous delivery term, infrastructure as code, automated testing, monitoring and logging, collaboration and communication, agile methodologies, automation tools, version control. These are the terms that you will hear a lot. So basically the continuous integration, I'm not going to spend time explaining these terms because the speakers are going to handle these terms in their sessions. So I'll just give a brief overview of what they mean, right? So continuous integration is basically ensures that every code the developer test is integrated as soon as possible. The continuous delivery basically ensures that the changes made to the software are automatically built, tested, and deployed to production. Infrastructure as code itself is basically has to do with the configuration and management of infrastructure. So we uses tools like Ansible, Puppet, and Chef. Then we have automated testing that has to do with unit testing, integration testing, and acceptance testing. And we have the monitoring and logging itself that has to do with tracking the system, like tracking the software to identify any issues or errors that may affect the system's overall performance. They also have the collaboration and communication, which basically is the whole concept that DevOps is found on. Like I said earlier, there has to be a form of collaboration and communication between the development and operations teams to ensure that the software is being released on time and updates are being made regularly to the software. There's also the agile methodology, like I mentioned, which is earlier, and we have agile methodologies that exist, like for instance, Scrum, SCRUM. Scrum is an agile methodology, and basically, like I said earlier, agile methodologies basically allow you to respond to changes in the software and give constant customer feedback. Then we have automation tools, like I mentioned that DevOps is built on automation. Like the whole concept of DevOps is built on automation. That's why it's used. That's why you hear of fast updates. That's why you know. That's how you hear that fast updates are being made. I mean, that's only possible if it was left to manual labor, that's not possible, right? So automation is basically the foundation of DevOps, and we have tools like Jenkins, Docker, and Kubernetes, which you have to familiarize yourself with in the future when you get deeper into DevOps, right? Then we have version control as well, like Git and the rest of them, GitHub. You'd have to basically allow developers make those code changes and enable the developers to track changes and also collaborate with others. So I've spent a lot of time discussing this concept, so I have to hurry and round up because of the other speakers I have to speak. So I'm going to end with this. So I believe that before you learn a concept or learn any technology, it's very important that you know the real life use cases of this technology, like be able to visualize and see, okay, so where can this DevOps technology be applied in my day-to-day activities. I'm sure everyone on this live or everyone that will watch this live video later would have used Google, Microsoft, Netflix, and Amazon. If you haven't used Amazon, I miss you have heard about Amazon and you know what it's used for, right? So these are very big, huge organizations, and these organizations all use DevOps. They all use DevOps. They all use DevOps to, perform practices or carry out practices like continuous integration and delivery, automated testing, containerization to deliver their new services and features, and also to deliver high quality software easily with speed. So these organizations leverage DevOps a lot to be able to, because you notice, oh, Google has added a new feature, you wouldn't even know, and all of a sudden it's working. Everything, like if there's a problem, they have resolved this, and it won't even affect the functioning of the application, right? The application will keep functioning normal, and the quality of the software you notice is very, very high. So you see that these functions are coming from DevOps. So DevOps is actually very, 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 very great field to actually delve into, as there are lots of use cases and it's a very highly demanding skill. So if you learn DevOps today and you learn it very well and become very good at it, you're rest assured that you get a job, right? Because these organizations are highly they are looking for developers, they're looking for DevOps engineers, and if you become very good at it, you not just be working in these companies, but you know that you're really adding value to the company, and thousands of people all around the world will be using that product, and you know that, okay, yeah, I did this, I did that. So that's basically the use case of DevOps, and I think I'll end with this because I spent a lot of time already speaking. So I think this is time where I would introduce Elvis and Anselm. So Elvis, please, can you come up and speak on your topic, please? Thank you.
All right. Can you hear me?
Yeah, I can.
All right. Cool. Hey guys. I'm super excited to be here. I'm just trying to upload my slides and then I would go. All right. Can you see my slide?
All right. Yeah, we
All right.
can.
All right. Cool. All right. So I'll be. Good job, Miss Deborah. Thank you very much. Right.
You're
So I'll
welcome.
continue from where she stopped. I would be discussing DevOps culture, right? Collaboration and communication that is in the workplace now. So yeah, so I think Ms. Deborah already explained what DevOps is, right? But yeah, still on that, DevOps is a combination of practices and tools, right? Including cultural philosophy that helps in the automation and integration of processes, between the different stages of software development and IT teams, right? So between the developers and the IT maintainers and maintenance team rather. So it's the process, all of the process, you know, between this stage one, between IT software development and IT teams, like it's said here already. So DevOps emphasizes on collaboration, right? Team empowerment, automation in technology processes, and cross-team communication. And going forward, you'll see that okay, this is the entire concept of having a culture in the practice of DevOps emphasizes communication and collaboration, right? Because you really cannot um, be productive or successful in deploying upgrades and improvements to your product if your team if there's no proper communication between the different aspects of your team, right? And this is where DevOps comes into play. So DevOps culture, fundamentally, DevOps culture is about increased collaboration and shared accountability between development and operations for the products that they create and manage. Right. So this takes me back to what I just said in the previous slide. Right. Only improved collaboration, right? Only when there is proper accountability between the software developers and the IT team, the maintenance team, would there be like a good or an efficient DevOps culture per se. So this supports, I mean, DevOps culture, it supports businesses by bringing their tools and their processes and their personnel into a more cohesive and customer focused manner. Once again, what this claims is teamwork, right? So yeah, DevOps culture it's equal. You can see DevOps culture equals um, efficient teamwork, basically. All right. So the DevOps culture mindset, the mindset you have to have when it comes to DevOps culture, right? Say you find yourself in an organization where you are part of the software development team, right? But you are the DevOps engineer there, right? This is the mindset that you should have in the workplace. You should be able and it should be open rather. Sorry, you should be open and honest in your work. Okay, this is very important. You shouldn't do something and then when you're asked, okay, why did you do this or when was this done or the reason behind your actions, then you lie because you don't want to take the brunt for it. So it's isn't encouraged. You should be open and honest with the work you do. You should learn to trust your partner, your teammates rather. You should learn to like place absolute and total trust in their work, right? Only then can you grow, okay? Because especially for us, and at the stage where we are as beginners, say you get an internship position tomorrow, you because you are still learning. That is, the essence of an internship position. You are still in the process of learning, but in a real life scenario, you should learn to like trust your teammate to like okay if this person says, especially when the person is more advanced than you are, you should like, okay, let me take what he said, let me put into practice what this person has said, and then see what comes out of it. You should adopt objectives that don't conflict, right? You should learn to accept failures rather than playing the victim, because not just in DevOps, right? As a developer, you would fail, right? At different stages, right? You face difficult moments, right? When you're writing code, when you're um, you know, running your code, debugging and all of that. All of these are failures, right? But learn not to play the victim. See them as okay. What's the problem here? Can I actually learn from this? And try and find a solution to them and move forward. Okay. So you should also create a shared sense of responsibility rather than the attitude of not my job. All right. So you can see where teamwork comes into play again. Like I've said repeatedly, this is like the entire encapsulation of what DevOps culture is. Basically, a good teamwork attitude, a good attitude in your place of work, right? Take the job as your job, right? Take more responsibility. Do not say, okay, because this is not my department, I cannot give to. Okay, forgive my language, right? But you get the point. So yeah, take it as if it was your own, basically. All right. So how to build DevOps culture, right? We've seen in the previous slide the mindset you should have towards a great DevOps culture in your place of work. So now how to build that culture. Um, you start by measuring each stage and metric. When when they say measure each stage and metric, it means take proper note of the of the numbers that you're getting, right? If you're succeeding in running something, for example, like not your success, not your failures, right? No, this just follows the deployment of DevOps principles. Really, you should take note of your KPIs, that is your key performance indexes, right? Measure them, as in take note of them, measure them against improved, or if you try and run those things again and you do not get as much success as you've gotten with the previous this thing, just take notes of this, compare them, analyze them, both before and after you run anything, right? And yeah, you'll be fine. Also, adopt open communication, adopt be open in your, again, teamwork, right? Don't keep your your cards to yourself, right? Open up, right? Poor passage of information, the poor use of expertise and labor, especially in the place of work, is um or are one of the most fundamental problems um when it comes to DevOps engineering. So, adopt open communication, right? There would most definitely be inefficiencies when you do not communicate with your team members, right? When developers who write the codes and, who writes the software do not communicate with the server admins, for example, right, who would install and manage the software, there is bound to be problems. So also start with small changes, right? Take small steps, take small actions, and then move on. Move on to bigger things as you go forward. Okay, so this is usually very safe, right? Beginning with a collaborative effort, right? Everybody contributing their little, and before you know, when you put all of this together, it forms, or it produces something very, very big and successful for the entire team. Also, accept your mistakes when they happen, because you will make mistakes, right? Nobody is perfect. Mistakes are bound to happen. So when those mistakes do happen, see them as a form of learning and accept them, right? Um, while trying to correct your mistakes, as you move forward. Um, Adopt proper budget planning. This is not for you as an individual engineer. This is for the organization, the company, right? Proper budget planning is a very essential element, right? That must be adapted in a DevOps team, right? Sorry. So taking stock of the organization's expenses when you're trying to transition and integrate products, it's very critical. So the organization has to like do this so that it doesn't waste money, right? And even lead to loss of productivity just because they do not plan their budget properly. So yeah, moving on. automation in DevOps. So yeah, with that previous slide, I am done talking about DevOps culture. So I'll be going to the next topic that I'm supposed to cover, which is automation in DevOps. Right. I think my colleague who is coming after me would talk. I think he will talk more about it. I'm not sure now, but I'm just going to give you like a brief introduction so you get an idea what automation is in DevOps, because essentially this is what DevOps is all about: automating processes, right? Automation in DevOps, automation automate everything, right? Quote and unquote. It's a key phrase in DevOps, right? What we try to do as DevOps engineers is to make sure we have systems in place, right, that are automated, okay? And it is this automated process, these automated systems that would ensure that, okay, whatever we're doing is successful. We do not always have to be at our decks 247 trying to like take care of things, right? We have already used tools, right, to make those processes seamless and needing less human interactions, right? So automation in DevOps, it just encapsulates everything, right from building the point where you start to build to the point where you start when you deploy to the point where you monitor. There are like different tools that you can use to automate these different processes. Benefits of automation in DevOps, right? Automation removes manual errors, which takes me back to the point about human errors, right? Because we are automating, we do not have to like babysit these systems, right? We've already set systems in place, and this would go a long way, in reducing human interference and errors. With automation, team members are empowered. Okay, you're confident that okay, I've done this. It would kickstart when it has to kickstart. It will stop when it has to stop. Dependency is removed. You're not depending on um, a fellow human being, because we are prone to errors. But with systems in place, all of those errors in judgments, errors in communication, errors in actions, they are removed. Latency is removed. There will be increase in the number of deliveries when systems are automated. Right, they will deliver when they are supposed to deliver. You reduce the lead time. You increase in frequency of releases. You provide faster feedback. Right, you get feedback faster when things are automated. You would automation also enable speed, reliability and consistency. Again, the fact that the human factor is removed from the process, from the entire process, right? You are almost promised a certain level, a certain degree of reliability and consistency in the entire process. Okay, so these are some of the DevOps automation, or the most popular DevOps automation tools that there are. There is Kubernetes. I'm pretty sure you've heard of Kubernetes and the monster that it is, but okay, no fear. When we get to that bridge, we surely learn and then we'll cross it. So Kubernetes is like it is a container orchestration and automation platform, and it is very popular amongst DevOps teams. It helps to manage containers at a very large scale, right? Containers. I know you wanted containers. Moving forward, we'll learn containers, not today. So Kubernetes helps us to manage containers at a very large scale, and it works with Docker. I'll talk about Docker later on. With Kubernetes, we can automate the management of hundreds of containers, like a lot of containers, and sorry about that. And it can be used, and we can use Kubernetes to deploy these apps, these containerized apps, to a cluster rather than using individual machines. Um, and there's Ansible Nest. Ansible is also an automation tool that helps us automate tasks that are otherwise repetitive, right? When I say repetitive, like tasks that you would have to, go back to go back to taking care of, right? And some of these include cloud provisionizing, the deployment of applications, and orchestration of intra-service. Um, it is an agentless. I mean, Ansible now is an agentless configuration management tool, and it is very easy to deploy. And it offers continuous delivery. CD. Ansible is also used to connect nodes and push modules to them from a centralized place. Um, Next is Docker. I think I mentioned Docker when I was talking about Kubernetes. So, Docker is a Linux-based open source platform essentially. Docker is a suite of DevOps automation tools, right? So within Docker, there are like different automation tools that creates containerized environments for apps that and this makes them more portable. The apps now it makes them more portable, more secure, and it reduces conflicts when testing the developed apps. Docker enables DevOps engineers to build and run applications quickly and efficiently, and many organizations that are looking to improve their infrastructure, they use Docker a lot. And Git, I'm pretty sure you've heard about Git. Git is one of the most widely used DevOps tools in the world. When Ms. Deborah was talking about some of the companies that use DevOps technology, like Facebook, Amazon, the Netflix of this world and the Microsoft of this world, right? These companies use Git, and they use this tool, and they use this tool because it is very popular amongst DevOps teams and contributors. Through its source code management model, the SM model, developers can track the progress of dev work and maintain different versions of the source code with Git, right? Git uses host repositories, such as GitHub. Another one I'll talk about, further down, such as GitHub, and it is on this GitHub platform that contributors can push their work. But I'll explain that when I get to GitHub. And okay, there's Jenkins. Jenkins is also an open source continuous integration server that automates the build cycle of a software project, and it is highly customizable. And finally, GitHub. Right, GitHub has been in existence since like I think the year 2000, and it has been one of the top DevOps automation tools for collaboration amongst DevOps. Not sorry, amongst developers rather. Um, Not only can developers make rapid iterations to existing code, right? Developers can go to the GitHub and change stuff about codes, make changes to codes, right? And as they are making these changes, their team members are getting instantaneous notifications, like live feedbacks about the changes that's happening. And because this is um enabled, this live feedback is enabled, they can get immediate rollbacks. But okay, say you go to your GitHub and then you change you make an iteration to a code that your team has deployed, but your team, the rest of your team would get feedbacks on notifications rather. I think notifications is a better word to use on this, and then they can immediately give you their feedback, right? In case you're making an error somewhere, so that there are no fallouts encountered, at any point. So this brings me to the end of my DevOps automation tools, and um, um, okay, sorry about that, and I'm confident that you've learned something today. All right. So yeah, I would drop the mic now and
Thank
let
you.
you come on.
Thank you very
Yeah.
much, Elvis. Thank you so much. Thank you for all that you have been able to share. The next speaker I'm going to call on is Umar Victor, and he's going to be speaking on monitoring and logging in DevOps. Hi, Umar. Are you here?
Hi guys.
Hi.
I hope you can hear me.
Yeah, we can hear you.
Yeah, we can hear you.
Can you hear me?
Yeah,
Okay,
yeah,
Yeah,
we
yeah.
nice,
can.
nice. So Deborah introduced me earlier, and if you are not here at the beginning, I'm Omar Victor, a software developer and technical writer. and it's nice to be speaking at our first biweekly event. And I'm going to be talking about monitoring and logging in DevOps. So I'm going to be using some slides. Let me share it. Can you see the slide?
Yeah, we can.
Okay, nice. So we're going to be talking about monitoring and logging in DevOps. And we're going to be talking about, first of all, we're talking about logging in DevOps. We're going to talk about what is logging, why do we do logging, types of logs, some situations where logs are super important, and the best practices during logging. First of all, what is logging? Logging is a process of recording events and activities in a system, such as user actions, errors, warning, and system status. Let's say, for example, a web developer, you are using the console.log to log out log out some values so that you can debug your application. In the context of DevOps, is almost, or should I say, the same thing. In DevOps, you have large scale applications and you are kind of looking for different kind of events, user events, activities that are happening on your application so that you can properly debug. If you run into an issue in your application, you can properly debug these issues. So logging is important in DevOps because it provides visibility into the behavior of a system, enabling teams to troubleshoot issues, monitor performance, and gain insights into usage patterns. By logging all events and activities, teams can more easily identify the root cause of problems and respond quickly to incidents. This can help to reduce downtime, improve system reliability, and enhance the overall quality. Why do we do logging? Why is logging important in DevOps? So as a DevOps engineer on your team and your logs are available to you, what do you do with these logs? You analyze it. You analyze these logs and use it in a way that you can be able to quickly debug any problem you have in your application. So the reason we record this set of events in our log, the reason we record this set of logs or events in our log is to find out what's wrong with our application. For instance, let me say something goes wrong, we can't our application is down, we can't use it or users can't use it. And you're called to rectify this problem as the DevOps engineer in your team. To find out why the error occurred, you have to look into the log files or the log server. The log file, if it's a small application, you can log it in a, let's say, a file, or let's say a database. A file will not really be ideal because you really don't want to store your logs in a file because you need some kind of filtering abilities. You need some kind of filtering abilities. So this and you can query your logs properly. So you are in your log server, and you want to find out what the problem is. Or your log server or your login is logging, let's say, a request, or each request that is made to that server. Your server is responding to with some kind of data, or is having some kind of data, and you're logging each of these requests. This request can be like a text file, let's say a text, and this request is, let's say, containing the status code of, let's say, it's containing the status code, the client's IP address, and some other information about the activities or events that are happening on that application. So you want to this the server crashes, and you want to log out all the events. You filter and you log out all the events that has a status code of 500, or all the events that the client IP is so so so, or whatever client address it is. Now you see where the issue is coming from this login, or from the logs you have already created. You can now, quickly debug and make your system operational, go watch Netflix or something on the Friday evening. So that's why logging is very important in DevOps. Next, we are going to be talking about the different types of logging in DevOps. There are different types of logging. There are lots, but I'm talking about just few of them. So there's application login, there's server login, there's network login. An application login just involves capturing data about the behavior of an application, such as user actions, errors, and performance metrics. These types of login can help developers to identify issues with the application code and troubleshoot errors that occur during runtime. Application logging can also be used to monitor application performance and to identify patterns that may indicate problems. You have um, you have infrastructure logging. Infrastructure logging involves capturing data about the performance and behavior of the underlying infrastructure and that supports the application, such as servers, databases, network, and so on and so forth. These types of logging can help operations team to monitor the health of the application and the infrastructure of the application. You have server login. Server login is just like logging the activities, all the activities in your server, and so on and so forth. Let's talk about the best practices for logging. What are the best practices for logging? One of them is One of the best practices for logging is using automation. Automating the monitoring process can help reduce the workload for teams, ensure consistency, and provide real insights. Automated monitoring can also enable teams to identify issues and anomalies faster than manual monitoring. Another best practice is to set up alerts. You want to set up some kind of alert system that alerts you when something happens or something goes wrong. You can maybe it can be a mail, or an alert on Slack that shows you that, oh, the server is down, or um, somebody is trying to hack into the system. You know, it can alert you. So you need some kind of alerting system. Another best practice is to use visualization tools. Visualizing metrics and other monitoring data can help teams quickly identify trends, anomalies, and so on. Visualization tools can also help teams correlate data and different sources and identify the root cause of issues more easily. Another best practice is monitoring your logs in real time. Monitoring logs in real time can help to identify the issues as they occur and can enable the teams to respond quickly to these problems. This can be done using log streaming tools, which can transmit log data in real time to centralized location for analysis and monitoring. That is it for logging. Let's talk about monitoring in DevOps. We're going to learn what is monitoring, the different types of monitoring, and the best practices for monitoring. So, what is monitoring? Monitoring in DevOps refers to the continuous observation of a system's health and performance. It is crucial for ensuring reliability and efficiency of the system. Monitoring provides the team with real-time insight into the behavior of the system, enabling them to detect and respond to issues quickly, often before they are even noticeable by the end users. In DevOps, where rapid iteration and continuous delivery are the norms, monitoring plays a critical role in maintaining the quality of the software and infrastructure, preventing incidents, and ensuring smooth operation of the system. Let's talk about the different types of monitoring. There are several types of monitoring in DevOps, but we'll be talking about few of them. One of them is one of them is application monitoring. Application monitoring involves monitoring the performance and behavior of applications running on top of the infrastructure components. This type of monitoring typically involves collecting metrics, data on key performance indicators such as application response time, error rate, and transaction volume, and using alerts and dashboards to identify the troubleshooting issues. Another one is infrastructure monitoring. Infrastructure monitoring involves monitoring the health and performance of physical and virtual infrastructure components such as servers, network, and storage devices. This type of monitoring typically involves collecting metrics, data on key performance indicators such as the CPU usage, the memory utilization, and network traffic, and using alerts and dashboards to identify and troubleshoot these issues. By using different types of monitoring, DevOps teams can gain better visibility into their systems and be better equipped to diagnose and troubleshoot some of the impending issues. So what are the best practices for monitoring? Here are some of the best practices for monitoring. Using automation. Manual monitoring can be time consuming and error prone. DevOps teams should use automation monitoring tools to collect metrics data, set up alerts, and generate reports. Automation can help to reduce the workload on team members and enable them to focus on higher level tasks. Another best practice in monitoring, just as we have in login, is setting up alerts. So you set up an alert to monitor any activities you're having on your server or your application, so that if there's any unusual activity or behavior in the server, you can easily pick it up and get notified about it. An additional thing I'll talk about is the tools that you use in logging and monitoring. Even though this is kind of more of a theoretical concept, it's also practical. It's something you can test out, but you can't really do that here because it will involve a lot of setting up and configuring and what have you. So some of the tools you use in logging and monitoring. One is Nagios. Nagios is an open source tool that is used for monitoring network services, servers, and application. It can monitor a wide range of metrics, including CPU usage, memory utilization, and network traffic. Nagios can also send alerts and notifications when certain metrics exceed predefined thresholds. Another one, which is like more popular, is Prometheus. Prometheus is an open source monitoring tool that is designed to collect metrics data from various sources, including servers, containers, and applications. It stores data in time series database and provides a query language for analyzing and visualizing the data. Prometheus can also set up alerts and notifications when certain conditions are met. These tools are just a few of the many monitoring and logging tools that you can use in your DevOps team. Thank you. Thank you. I've come to the end of the topic. Thank you. I hope you are able to learn a little bit about logging and monitoring in DevOps.
Thank you so much, Victor. That was very good. Thank you. I would like to call on the next speaker because we're like kind of out of time. Treasure Obisike is a full stack software developer, very experienced, and he'll be speaking to us also. This will be the last session, so I hope you've been learning, and I hope this session has been great so far. So, Treasure, please, can we have you?
Yeah, good day, everyone. Obisike Treasure, like she said. Nice to be part of this community. Yeah, I'll be talking about DevOps tools and also CI/CD. I'm trying to display my slide now, so just give me a moment. Let me get it to. Okay.
That's fine. So as Treasure displays his slide, if you have any questions, please let us know in the comment section. I will attend to it. For people that would watch this live video after the live recording afterwards, if you have any questions and you're not in part of the community, you can join DLS community and send us the questions within the community. I will definitely attend to it. Yeah. And if you'd like to know what this session is all about, you can check the description in the YouTube video, and you would know what we have covered so far. Basically, thank you so much. Hi, Treasure. Please, have you been able to set up your slide?
Okay, so can you see my screen now?
No. Give me a second. Sorry, can you try sharing? Have you tried sharing? Okay, now I can see it. Yeah, we can see it.
Okay, I'll be talking about DevOps tools and also continuous integration and continuous delivery. Firstly, we need to understand what DevOps tools are. DevOps tools are a collection of softwares that enable and facilitates DevOps methodology implementation. These tools can help to automate, can help collaboration and every other aspect of DevOps that is very, very needed and necessary. Then these tools can be classified into several sections, several categories, one of which includes the monitoring and logging tools, the collaboration tools, the containerization and orchestration tools, the testing tools, the cloud infrastructure and service tools, the version control tools, the infrastructure and automation tool, and the CI/CD tool. So we'll be discussing about each of these tools one after the other. The first tool on our list is the monitoring and the logging tool. The monitoring and the logging tool are those tools that assist us to monitor our DevOps pipeline. They are tools that they are softwares, applications that can help us monitor things. An example of one of these tools is the Prometheus and Kibana. Then the next categories on our list is the infrastructure automation tools. The infrastructure automation tools are just basically tools that can help us manage our infrastructure that we've set up. They can help us provision infrastructure. What this means is that, for instance, now we have a cloud provider, such as AWS and the rest. So sometimes we need to provision servers on those cloud provider. We need to actually set up servers, not just provision. We need to set up, update, and do everything on that server. The traditional way is just to manually go to the site, get the provision the server from the site, then start passing instruction one after the other, or even writing a bash script to do that. But with this DevOps tool now, we don't need to do all that anymore again. We just need to have a particular file that contains our configuration. Then we just execute it. So this infrastructure automation tool contains the configuration management tools, the resource provisioning tools, and many other tools. An example of this infrastructure automation tool is the Ansible and Terraform. They are the most popular one that we know of. Then we'll move straight to the cloud infrastructure and service tool. The cloud infrastructure and service tools are basically those cloud providers we have. We have the major ones like the AWS, the Google Cloud Provider, Azure. We also have the likes of Vultr, Linode. All those are cloud infrastructure tools. They are providers that we can use to provision servers, provision databases, and many other stuff. They are really amazing. Then move forward to the testing and debugging tools. Testing is one of the major part of software development and DevOps itself. Without testing, DevOps will just be pushing out apps that are buggy, that are not working, and will basically lose customers, and people will not use the product well because of that. So there is a need for us to have tools that we can use to test our product before it will go live. Now, these testing and debugging tools can be divided into two categories too. We have the manual testing tools and the automatic testing tools. The manual testing tools An example of the manual testing tool is Selenium and JUnit. They offer like a sandbox where you can test your application before you actually like move it live. There are many other testing tools out there too, but if you have the time, you can go and investigate more. Then for the normal automatic testing tool, we have the Visual Studio Debugger. We have the Test Link and the Test Rail. Those tools allow us to test the application during the pipeline, the DevOps pipeline. So move next to the collaboration and communication tools. The collaboration and communication tool obviously is very important in the whole DevOps, which means developers and operation managers. There's a need for them to communicate. Like there's a need for there to be a medium by which both teams will communicate seamlessly. So this is also an integral part of DevOps itself. And since it's an integral part of DevOps itself, they need to be a tool that can handle that kind of communication. So an example of these tools, you know them are like Slack. You have your Slack, you have your Jira, you have your Microsoft Teams, where you can easily create boards, track the boards to the end of the pipeline, track updates and the rest, and even communicate too. Then we move to containerization and orchestration tools. This one is one of the most familiar set of tools in the DevOps space in general. So they're just tools that we can use to package our application in such a way that it has everything it needs for it to run without any external party. So an example of this orchestration tool is the Docker. Docker is a containerization tool. Like you can use Docker to package an application and run it on any system anywhere in the world. So it's the orchestration tool. An example of an orchestration tool is Kubernetes. Kubernetes is just a container orchestration tool that helps manage, provision, and organize containers there. Then we move on to the version control system tools. The version control system tool are tools that allow developers to collaborate, like to drop their codes, make updates, and many more. It provides a repository where developers can track their changes, update their workflow, and even change itself. It stores the code. An example of the version control system tool is the popular Git, not GitHub, Git. Git is a software that can track changes and also provides a repo that you can actually store codes to. Then we'll move on to the next. The continuous integration and continuous delivery tools. Yes, this type of tool, we'll talk about them we'll divide them into two, which are the continuous integration and the continuous delivery tools. The continuous integration tools are just basically tools that allow us to do things like building, testing before we now integrate it to the main code. Normally, the DevOps cycle portrays a series of steps, a series of process before we can get to the endpoint. So these CI tools allow us to like perform most of those operations before we can get to where we can deliver the code or store the code. Yeah, an example of this continuous integration tool is Jenkins, GitLab CI/CD. They are very popular ones. Then the continuous delivery tool are still almost similar to the continuous integration tool. They are tools that can help us deliver deploy the application or deliver the application to its final destination, either to the customers or to the server where it's supposed to stay, production. So an example of this tool is the GitLab CI/CD and Jenkins too. Then we are done with everything about the DevOps tools. Now we're talking about the continuous integration and continuous deployment, what it entails and everything about it. Okay, CI/CD, as I said before, can be divided into two: the continuous integration and the continuous delivery. The continuous integration is a process of automatically building, testing code changes, as well as they are made, and ensuring that the code is always functional and deployable. Then continuous delivery is just the process of automatically deploying code changes to their target environments after they have been built and tested. So CI/CD, from what I've read of now, CI/CD CD follows after CI. So that means the CI process must be completed before we can move towards the CD process. So here it's is a diagram explaining the CI/CD flow. So as you can see, it's like an infinite symbol that is connected to each other. This is just implying that the CI/CD flow is something that can move from one point to another and back to the point seamlessly without any obstruction. You have the code, you build the code, then you test the code, then you make a release to the environment you're supposed to make a release to. Then the release can be stored in your repo. Then you pull the release and deploy it. Then you pass it to the operation this thing. Then they'll monitor it for any this in breaking or update or something like that. Then it goes back the cycle again. Now we have to discuss about the advantages of CI/CD. Well, CI/CD offers a faster time to market. Like with CI/CD, you can easily just get deploy features quickly, seamlessly without any issue at all. It's a very smooth process. Then we move on to the low cost. Yes, obviously, when everything is automated, the cost for building, testing, and moving throughout the whole flow is tends to be cheaper. You don't have to, like, every time you want to deploy something, you have to get a full someone that would go through the whole thing. There's someone that will do this stuff, then pass it to the operations team and all this kind of stuff. You can just have one person do the whole flow and it's over, just to monitor the whole flow and it's over. Then we move towards increasing quality. Yes, as CI/CD provides this seamless integration of code, it also can improve quality because now developers can focus more on building their code and the operation team can focus more on delivering it, like just monitoring the delivery process and ensuring that there are no bugs. Before bugs can pass through the CI process, it must be something that has been permitted. Normally, on a normal node, the DevOps flow usually is to have several environments. Some of them is to have the staging, the development, the local, the production environment. Before something can move to the production environment, it must have gone through all the three other environments there, the staging and the rest. So now, when a code is being built, like when the developer finishes writing his code, passes it through the pipeline, he pushes it to his repo. Then the repo runs actions or runs runs the CI/CD to be able to deploy to the particular environment. It does what we call testing during that process, testing, debugging. If there's any bug, it sends it back again. It rolls back again for the developer to update it seamlessly without disrupting the production environment and the development environment. So now when a release is made, it doesn't affect the one that's already live. Right, the one that is live will still be live until the whole CI/CD is completed. Once it's completed, then it's been deployed. Then to replace the one that is live. With this, you can have less downtime, very little downtime. Now move on to improve collaboration. Obviously, by using Git, which is a part of the CI/CD tool we know of, you can easily collaborate with developers, add features easily, and so on and so forth. Then we move on to the disadvantages. Obviously, if something has advantage, it should have a disadvantage. The disadvantage of CI/CD includes, yes, it's very costly to set up. Obviously, the phrase that when you want to do something, you want to automate something, it will take you a very long time to actually create the flow that will automate it perfectly without error. It usually takes a long time. Then complexity, yes, it also increases complexity too. Most of the time, if you have a simple application you just want to just build and just push up there, or you have something that you just want to just build and just deploy, if you are following the CI/CD process, it might take a longer time. Like it might become more complex in the sense that you now have to start passing your application through several stages when you know that you can just deploy it straight immediately. It's very simple application. Then move on to the dependency and automation. Dependency on automation. Yes, obviously, CI/CD is very, very dependent on automation. It is benched on automation. In fact, the whole of DevOps is mostly benched on automation, and this can also be an issue most of the times. Then lack of human oversight. Well, as much as we want to make things automated, there's still a need for some. There are sometimes where humans have to be involved to spot out things that may go wrong, that the systems can capture. So due to the use of this CI/CD, it's due to the elimination of human efforts or human addition to the whole pipeline. We can have some set of bugs that cannot be captured by the machine go live without issues. Then security risks. Well, since we are putting all our eggs in one basket, it's easier for hackers or any other third party that wants to harm your application to easily at some point of your CI/CD pipeline involve itself and get out keys they need and attack your application. Anyways, we've come to the conclusion of everything. Throughout the whole this thing, we've discovered that DevOps tool has become an integral part of software development and IT operation. That these tools enable automation and streamline the software development and development process, deployment process, allowing faster and more reliable delivery of software products and services. With wide range of DevOps tools available, it is important to understand that the different categories of tools and their respective purposes to choose the right tool for a specific need. Also, by adopting and leveraging the right DevOps tools, organizations can strive and can stay. So it can survive in the fast growing development space. And also, we also have learned that CI/CD is very important, and it has a lot of advantages that can help our large projects be functional and will help us deliver quality goods or quality products. Thank you.
That was so great. Thank you. I've seen a lot of nice comments. I hear you, Boss Treasure. Man, this is good information. Thanks. Yeah, you're welcome. And the other sessions that we'll have in the future, in the next 2 weeks, we'll be having another event where we'll discuss topics that will be covered in the curriculum. And I promise this will be better than this and even more, informative. So thank you so much for everyone that joined us today, and for as many of you that would watch the recording afterwards. If you're interested in joining the DevOps Learning Space community, just send us a message on Twitter. I will add the Twitter handle for DLS to the description in this video or to the YouTube channel, so you can easily send us a message on Twitter and we'll add you up as soon as possible. Thank you so much, guys. Thank you, Uma, Victor, Treasure, and Elvis. Thank you so much for your time, and thank you for taking your time to share this knowledge with us today. Okay, so we have some questions. One from Martins. Please, can you explain more on orchestration? So please, can you explain more on orchestration?
Okay, orchestration. Orchestration is just basically like managing containers. For me to talk about orchestration, I'll need to like discuss about containers too. Containers are just like snapshot of your application. So orchestration is just basically managing those snapshots, like managing the whole process of those snapshots, deploying them, scaling them when necessary, like horizontal scale and vertical scaling, then deleting them when they are no more needed again seamlessly. So there are tools like Kubernetes that can help facilitate this orchestration process. Kubernetes provides a CLI tool called kubectl that can allow you to seamlessly deploy your container with everything it needs. It can also allow you to provision things like extra nodes to make your server more responding. Then also it can also help in things like load balancing and some other stuff that are necessary for your application, or even DNS too. If DNS handling too, it also helps with that too. It's also good. It's also very good with security. So this orchestration process now involves all those things together, just managing the containers that you have and managing their states on during deployment. So I hope I've been able to explain it to you.
Okay, so hi Ephraim, can you let us know if sorry, hi Martins. Please can you let us know if that explanation was okay for you, if you were able to understand what orchestration was. Thank you. Sorry, Treasure, please can you mute yourself? We can hear you. Okay, someone said I'm currently working on a Linktree clone. Please, how does DevOps play out in such a project? Can someone take that, please?
Okay, Ephraim asked the question, how does DevOps play out? He's building, said you are building a project, a link tree clone, and you're asking how does DevOps play in with such an application. If you're getting into DevOps and you want to start implementing DevOps into that kind of application, you can start with something like, let's say, CI/CD, or automating basic tasks on your project, like um, automating the build process, so you don't manually have to deploy your application. When you push changes to GitHub, you create some kind of pipeline where once you push your changes, it automatically deploys to both a dev server and the production server, and you can see your application or the latest changes in your dev server before uploading it to your production server. So something as nuanced as that, you can start with something as nuanced as that and keep on adding more, let me say, adding more things like alerts, or some kind of alerting system where you can get notifications if your site was to go down. So that's my answer to Ephraim.
Thank you. Thank you so much, Victor. Ephraim, I hope that was able to answer your question. If there are no more questions, we would call it a day. Okay, so thank you so much, guys, for joining us today. Bye.